Okay, so this video is going to talk you through how to trace recursive algorithms for the IB Diploma higher level papers. On here you can see there's a few things you need to do with recursion in Unit 4. First thing is define the term recursion. Now this has come up on a previous past paper. So if we look at May 2018 high level paper 1, all you need to remember for this section is that it's a process or method, procedure, subroutine, function, etc. that calls itself. Okay, so in terms of Java, they're methods that will actually call themselves inside the method itself. Now it does say here, describe the application of recursive algorithms, and pretty much the answer for what you need there is given in the specification. So just be aware that it's only applied to a small subset of programming problems, and also that recursive algorithms are rarely used in practice. Now, D.4.3, construct algorithms that use recursion. This has never come up in any exam so far. There's been some that they've given you the recursive ones and you have to use a non-recursive method, but nothing where this has actually been addressed specifically. So I'm not going to cover that on here. So this is going to be our main focus, which does come up quite often, and that's tracing recursive algorithms. And it does say all steps and calls must be shown clearly. So let's take a look at a recursive algorithm here with a factorial example. A couple of things that are really important to note in any recursive algorithm. There has to be a base case. This is a statement where the recursive algorithm will start to finish. If this doesn't exist in the recursive algorithm, then you would get into an infinite loop. So in this case, x is going to be constantly lowered from its starting value every time it's passed to a new call, and eventually it will hit 0, which will return 1, and then the recursive methods will start to finish. So let's have a look at how we would trace this. Now, one thing I want you to note is in this example there's only one recursive call, and that's going to make a difference in how we trace these algorithms. So in this case I'm going to use a trace table. So let's draw out a table here. Okay, I'm going to put level to show the level of the call that's been made, and that will start at 0. And then after that I'm going to write down my variables that are in the program. So in this case we've just got x. I need to include any if statements. So there's x equals 0, which is this one here. And finally, there's a return. So we need to know what this algorithm returns. Now for this example, let's put the number 3. So if x is equal to 3. Okay, so we start working through now. Is x equal to 0? It's not, so I can put false here. So that means we're going to go here. Now, the answer is x times factorial x minus 1. So I know this is 3, but I don't know what this part is yet. So I need to work this out. So to do that, we need to create a new level. And we need to pass in the value here, which is x minus 1. So that's going to be 2. Now, this is a whole new method. Okay, so now x is 2. And we start again. Is x equal to 0? It's not. So I need to return 2 multiplied by factorial minus 1. Again, I don't know what the answer to this is. I do know 2 minus 1 is 1. So we need to do another call. So that's going to be level 2. And I'm going to pass the value 1 into here. So again, now, what's actually happening here is as the next call is made, the previous one, so in this case this one, and this one, are placed on the stack. It doesn't mean we're finished with them yet. There's still a calculation that needs to be done with these levels. So once we've managed to finish one of these calculations, then we will start moving back up the stack to complete the program. So at the moment we're on x equals 1. So 1 comes in here. Is 1 equal to 0? It's not. So we know now it's 1 multiplied by x minus 1. Well, 1 minus 1 is going to give me 0, and that's going to be my third level with 0 coming in, so it should be in false there. Okay, so now we come round again, x equals 0. At last, we've now hit the base case. Now, this is true, and we can return 1, and we move back up the stack. So now we know on this level, on level 2, we know x was 1, and we've got 1 multiplied by whatever was returned from the stack below, which was 1. Okay, so 1 times 1 is going to give me 1, and then that's going to be passed up the next level. So if we move back up, on level 2 has now been completed. We're now up to here. On level 1, x was 2, multiplied by whatever got returned, which was 1. So it's 2 multiplied by 1, which is going to give us 2. And this will then return to the layer above that, where x was 3. 3 multiplied by 2 will give us 6. And then that will be sent back to whatever called this method and would likely be output. So the answer in this case is 6. Looking at this example here, this is slightly different. In this program, the Fibonacci recursive method, we've got 2 recursive calls. So we've got to be careful with this one. If we try and put this into a trace table, it can get quite confusing quite quickly. What I'd recommend if you've got 2 recursive calls is that we use a tree to show this. So let's put in the example where x is 4 into this method here. So I'm going to put my first level here. I don't know what the answer coming back from that is yet, but I do know x is equal to 4. So is x equal to 0 or x equal to 1? It's not, so I can't return 1. So I need to return Fibonacci x minus 1 plus Fibonacci x minus 2. I don't know the result of either of these. I need to calculate both of them. So this first one here, I do know I'm going to send 3 to. So I can say x equals 3 to this one. And this one here is x minus 2. So this one is going to be x equals 2. Now I can't do these all at the same time, so what we're going to do first is work on the left hand side of the tree. So we come down here, x is now equal to 3, it's not 0 or 1, so again, I've got the same problem. I'm going to have to work my way down. So x minus 1 is 2, x minus 2 is 1, so here is x equals 2, here is x equals 1. And we go again. So now x equals 2. Again, it's not 0 or 1. So I've got the same issue again. Now all of these are going to be, the result of these are going to be added together. So I can put this here just to show that. So x minus 1 is 1. So I know 1 will go here. And this one is going to be 0, so I know x equals 0 is going to go here. Okay, so the first one, we're going to work down the left still. X is 1. At last, we've hit our base case. This returns 1. Okay, and that's finished. That's a base case call. Doesn't go any lower. Now on the other side, we know x equals 0 is also going to return 1. So that returns 1 as well. So now this actually tells me that the calculation that I needed for x equals 2 here is going to be 1 plus 1, which means this will return 2. Great, so that's that part of the tree worked out. However, 2 plus what? Now, this is where it gets a bit easier. I've already done an x equals 1 call. So I can then take the value from down on this side here and use that here. So x equals 2, x equals 1, 2 plus 1 is going to get 3 coming up. 3 plus, okay, I don't know what to add to 3 yet. So I've got to do x equals 2. I've already calculated that. I know that is going to come back as 2. So I can do 3 plus 2, and that will give me 5. Now, to be completely accurate, I should draw this out as well to show the base calls were hit here and here. Okay. As you can see, this is a much easier way to visualize two recursive calls in the same method. So let's look at a past paper example now. This is from May High Level Paper 2 in 2019. So the following recursive method has been written to act on the list guests, which we've got a linked list at the top there. So we've got a recursive call. We've only got one recursive call there, so I can do this in a trace table. Let's start with level 0 here. Okay, now actually on the question paper here, this is a recursive call with the values 0 and f being passed in as the parameters. So k is 0, a is f, and we can start then working through. So does 0 equal the guest size? Well, there's 4 people in the list, so the answer to that is no, false. Else the visitor equals the current guest, so we're looking here at the moment at Anna at this level, so she is 0. Does her gender equal A? What it does, yes. Is she older than 15? She's not, so that statement is going to be false, which means we've now got a recursive call. So we're going to go down to the next level, k plus 1, so that's going to go to 1, a remains the same, stays as f, and we go around again. So now we're on 1. Are we at the guest size yet? We're not. Does the visitor, okay, so we've got to get the next visitor. So the current one now is item 1, which will be Ben. Is Ben female and greater than 15? He fails both of those tests. So I should have put a false there before, but he fails both of those tests. There's a false here as well, which means then we've got another recursive call. K plus 1 is going to go to 2. We're going to move to level 2 on the trace, and we're going to go around again. So does the guest equal the size? No, k is now 2. It's not 4. And we now get the guest, which is going to be 2, which is going to be Daphne. Is Daphne female? So I should put false. So we've still got female here. Got false for the size. Is Daphne female? Yes, she is. Is she greater than 15? Yes, she's 16. So we've hit our true, and we've hit our base case here. So output current dot get name. So the output here would be Daphne. Now, in theory, the recursion would then move up to the next, to the previous call, and up to the previous call after that, but there would be no outputs there, because this is where that recursive call happened. So once the recursive call is finished, nothing takes place. So you would just get Daphne that would come out of this example. Okay, I hope that helps you answer some of these questions.